Hello, and let's look at some ugly looking equations. Now ugly is a bad word to use. It's just that I don't know what other words to use. I'm just going to call it ugly looking equation. I'm going to pick up 3 questions from CAT 2020 slot number 1 and see how we can navigate these ugly looking equation. Now let me ask you something. How good are you with respect to visualizing? So can you see how a particular function looks like? For example, if I say ax squared plus bx plus c, which is a quadratic equation, do you know how it behave? You know that this behaves like a parabola. Now, would you also know that this parabola will be in this fashion, so in this shape, when a is greater than 0, and if x square coefficient is negative, when a is less than 0, the coefficient of x square is negative, is going to be an inverted parabola. Lot of value is going to be negative. Here the lot of value of that function is going to be positive because it's going to go like that. If I ask you how does x plus 1 by x looks like, can you plot that graph? At least do you know how this graph behave, how this function behave. Now what is interesting with an x plus 1 by x as a graph is that the point 1, obviously it is not defined when x equal to 0 because we got 1 by x. So when the point is 1, when x equal to 1, it's going to take the value which is equal to 2. 1 plus 1 by 1 equal to 2. After that, let's take the value 2, 2.5, 3.33, 4.25, and so on and so forth. This probably is going to take a journey like that. What about, let's say the point is half? So which means somewhere here. What happened this side, 0 to half. If it's half, will be half plus 2. 2.5, it's probably going to increase, right? So this is going to shoot up, and when this value of x is very close to 0, because 1 by, let's say 10 to the power of the, so let's say 1 by 10 to the power, 1 by 10 will be 10, 1 by 100 will be equal to 100. It's going to shoot up and go to infinity. And on the left hand side is going to behave probably in the similar fashion. When it's negative 1, this is going to be equal to negative 2. And then here is going to behave like that, and then it's going to go like this. So that is how this function x plus 1 by x looks like. On the positive side, the minimum value of this function that it can take is 2. On the negative side, the maximum value it can take is negative 2. That's how this function behaves. The question that I'm asking is that if I ask you how does the log x behave, can you draw a function of log x? How can you visually look at a particular function and say that this is probably how this function behaves in a graph? Now the reason why I'm specifically talking about this is to help you understand in some of the ugly looking equations, this visual representation helps. There are a lot of other ways of solving this question. I'm just picking up one method, which is a visual representation of the questions would help. So let's, for example, look at this question from CAT 2020 slot number 1, and we have an ugly equation here, which is 2 to the power of x plus 2 to the power of negative x on the left hand side equals 2 minus x minus 2 the whole square. And the question is asking about number of real valued solutions. Number of solutions. When I look at this, you have something which is on the left hand side, a function which is going to be very different in terms of how the right hand side function is behaving. The right hand side function is a quadratic function. Now this quadratic function, if you look at this quadratic function on the right hand side, this quadratic function, if you expand this will become 2 minus x minus 2 the whole square, will be 2 minus x square minus 4x plus 4. That will become negative x squared plus 4x minus 2. This is a parabola which has got a value which is negative, right? So it's going to be an inverted parabola. That is the thing that you see in the left hand side. You may even look at plotting this graph. The easy way to look at this graph is when x equal to 0, this value would be equal to, when x equal to 0, if you actually look at the value 2 minus 0 minus 2 the whole square, negative 2 the whole square is equal to 4, 2 minus 4 will be equal to negative 2. So this fellow is going to be negative 2, and the maximum, this is obviously going to start from here and chip. What is the point? What is the maximum point? And it's kind of obvious to look at the maximum value here. You actually see x minus 2 the whole square is going to be a positive quantity. It is going to be a positive quantity. So which means 2 minus a positive quantity. What is the maximum value? The maximum value happens when this quantity becomes equal to 0. That happens when x equal to 2. So when x equal to 2, this will be equal to 0, the value will be equal to 2. When x equal to 2, this value is going to be equal to 2, but this particular function is going to look like that. So at least you can look at right hand side and say that right hand side is a function which is greater than or less than or equal to 2. You probably need not use the graph to at least come to that conclusion, but I'm just using the graph to visualize how it looks like. So right hand side function is going to be less than or equal to 2. Now you can also use this to figure out the maximum value as well. There's no harm there. The maximum value happens for, let's say, ax squared plus bx plus c, a function, the maximum or the minimum depending upon whether it is inverted parabola or the direct parabola. So if it's a normal parabola, then this point will be a minimum value. Inverted parabola, that point will be a maximum value. Whatever that happens, that particular point happens when x equal to minus b by 2a. Right? I hope you know that. So in this case, b is equal to 4, so that's been negative 4 divided by 2 times a, in this case is negative 1. So that becomes when x equal to 2. So the maximum value in this case, because it is an inverted parabola, it will want to have a maximum value. That maximum value happens when x equal to 2. When x equal to 2, this value would be equal to 2. That's how the right hand side is going to behave. Let's look at how the left hand side is. Left hand side, one thing that you see about left hand side, this is 2 to the power of x plus 2 to the power of negative x. Now imagine, for example, if you're putting the value x equals to, let's say, 2, right? There will be 2 squared plus 1 by 2 squared. That's what that means, right? That will be equal to 4.25. That's a value. 4 plus 1 by 4 is 4.25. What if x equal to negative 2? This becomes 2 to the power of negative 2 plus 2 to the power of 2, which is 1 by 2 square plus 2 square is again 4.25. A couple of things that you notice on the left hand side, this is always going to be positive. This function is always going to be positive. And second, it's an even function. Whatever happens on the right hand side of x-axis is same that is going to happen on the left hand side. It's going to even function. Plus this is a function which is 2 to the power of x is going to shoot up really fast. Where will these two people meet? Where will they meet? So when x equal to 0, what is the value? When x equal to 0, this will become 2 to the power of 0 plus 2 to the power of negative 0, which is 2 to the power of 0 is 1, 2 to the power of negative 0 is also equal to 1. This will meet when this thing is equal to 2. And after that is going to shoot up. These two functions is never going to meet. There will be no solution whatsoever. Or another way to look at this is this function on the left hand side would be something that is definitely greater than or equal to 2. Yeah. It's probably kind of similar in this case of x plus 1 by x. X plus 1 by x is always on the right hand side would be definitely greater than or equal to 2. Same thing that we just discussed. This is 1 by 2 to the power of x plus 1 by 2 to the power of x is also behave in a very similar fashion, at least from the minimum point of view. If at all these two functions, so you've got answer to be 1. You can, if you can think of these at least, if this strikes you, we know that the only way these two fellows can meet is when x equal to 2. That's the only way. But when x equal to 2, the value of left hand side when x equal to 2 would be some 4.25. And the right hand side when x equal to 2 is equal to 2, this is not going to work at all. I have not drawn this to scale. All that I'm saying is that if you think about these equations visually, you might get some ideas about how does the equation behave. If you, for this particular question, if this one strikes you, it's wonderful. Then the answer is there. If that does not strike you, then maybe visualizing this might help. The number of distinct real root of the equation. Now you have got the equation again. We can see that x plus 1 by x the whole square minus 3 times x plus 1 by x plus 2 equals 0. You already see a couple of things. I know how x plus 1 by x behave. Okay, x plus 1 by x, at least I know how it behaves, and I can already see a quadratic function here within that. So if I for a moment think about this particular equation and call x plus 1 by x equal to, let's say, some value which is equal to z, this equation becomes z squared minus 3z plus 2 equal to 0. Now this is manageable. Now you have z, this would be z minus 2 into z minus 1 equals 0. Now there are two solutions that is likely possible, z equal to 2 and z equal to 1. Now it is tempting to mark 2, but this is not some random z. This z is equal to x plus 1 by x. Right. So is it possible for x plus 1 by x to be equal to 2? Yes, it is. All we need is when x equal to 1. That makes sense. Is it possible for x plus 1 by x to ever be equal to 1? Think about that. It's not possible, because our x plus 1 by x ever be equaling to 1 is not possible at all, because on the right hand side the minimum value it can take is 2. The minimum value x plus 1 by x is going to take when x equal to 1, that's equal to 2. Therefore this one is not possible. There's just one value that is possible, which is equal to 1. Let's look at number 3, the area of the region satisfying the inequality. So you've got 3 inequalities and we have to look at the region that satisfies inequality. This is now these two things. You've got number 1, number 2, number 3. Number 2 and 3 is fine. This can be managed. There is nothing, no difficulty in managing number 2 and 3. This is my x, this is my y. Y has to be positive, which will be this graph, and y is less than or equal to 1. So we have got this line which is saying that will be equal to 1. So currently these two has restricted the region here. And now all we have to take care of this one. So another kind of graph that you should know is how does modulus behave. So if you have y equals to modulus of x, you know it's a linear graph. It's just that modulus kind of makes it change direction. It's just a linear function. It's going to be a straight line, just that it's going to change direction. So I would want to first of all write this in terms of y. That's the first objective that I have, right? So this will be, if I take negative y is less than or equal to 1 minus modulus of x. Now I've got a negative y here, so let's consider into y. So y therefore would be greater than equal to modulus of x minus 1. That makes sense. No? Does it? So you have negative 2 is less than, let's say, 1. Therefore 2 would be greater than negative 1. So when you change the sign here, you also change this particular sign. So when you want to change the sign, you have to change the sign as well. So the basic thing that you're doing is you're multiplying it with, if you're multiplying it, so you've got negative 1, you change to y. You change this sign as well, greater than or equal to. If you change the sign, this is you change the sign here. So 1 minus modulus of x will become modulus of x minus 1. So this is something that the basic funda of inequalities. But modulus of x minus 1, when x equal to 0, this will be equal to negative 1. So we have that particular point which is equal to negative 1. And after that, this modulus is going to go in this particular fashion. And essentially now the question boils down to, how do I figure out this area? That's it. Now, so couple of things that you almost thinking, oh my goodness, I'll have to figure out when these points are there. If I can figure out that point, if I can figure out that point, at least I can figure out this area here, and maybe that area, or maybe if I know the formula of trapezium, I can understand this area, multiply that by 2. If anything can be done, all we need to know is these points, and this is easy. So you're looking at this function, right? So this will be equal to y equals to modulus of x minus 1. And this particular point you have got y to be equal to 0. When y equal to 0, that will be equal to modulus of x minus 1. So modulus of x will be equal to 1, or x will be equal to plus or minus 1. This will be a value which is negative 1. This will be a value which is plus 1. This makes sense. And this particular case, you have got y to be equal to 1. That's the point, right? Y equal to 1. I think that this is manageable. So there, if y equal to 1, 1 should be equal to modulus of x minus 2. Minus 1, sorry. Which means modulus of x should be equal to 2. This is plus 2 and minus 2. I think that's all we need to bother about. So I think there are a couple of ways you can do it. If you don't know the formula of trapezium, this is 1, this is 1. So this area would be equal to 1. And this area is what? This base equal to 1. This height is equal to 1. So this will be equal to half. And therefore this will be equal to 1. This will be equal to half. We got 1 plus 1 is 2. 2 plus 1 is equal to 3. The answer to this question is 3. There you have it. So the point that I'm making here, ladies and gentlemen, is that you, in knowledge of in general graphs and how does the function behave, is very useful in visualizing and solving some of these questions. I hope this made sense. If you have any doubts, please put in the comment box and I'll probably address those things. Bye.